Okay, so in this question, we are going to actually review a few things. So we're going to review the domain. We are going to review equation of a tangent plane. And then we're also going to review directional derivative all at once. Okay, let's start with the domain. Now, if you have log, I want you to remember that the domain is going to be the boundary of the domain has to be dashed, not solid, because log of 0 is undefined. However, if this was the square root of 3x plus 8y, then the domain would include a boundary that is solid. So I know this is going to be dashed. I immediately will change this to this option. Now, this option requires me to, first of all, figure out what's going to be the boundary. So the boundary happens when the inside is actually equal to 0. So set the inside equal to 0. This is going to be equation of a line. Now, if I solve this for y, I guess I could solve this for y, but I just need 2 points. So for example, this line definitely goes through 0, 0. So that would be one thing, 1 point. And I just need one more point. So maybe if I choose negative 8 for x, and if I choose 3 for y, that would work. So I think that another point would be here, negative 8, positive 3. I'm not really sure I have space. 1, 2, 3, 4, 5, 6, 7, 8, negative 8 and 3. So something like that. That's going to be the boundary of the domain. And then I will just need to find a test point and figure out if the domain is above this dashed line or below the dashed line. But let's see if we can already draw the line. So it'll go through 0, 0, and it's also going to go through negative 8, positive 3. Okay, I got that. And now I just have to decide what is it going to be, top or bottom. So I need to take a test point. Now, never, ever, ever, ever pick a test point that satisfies this equation. You cannot pick a test point 0, 0. Pick anything else, but it shouldn't work when you plug it into the equation. So for example, I can pick, I don't know, x equals 1, y equals 0. How about that? So that's my test point 1, 0. Now, I need to make sure that 3x plus 8y is greater than 0, strictly. Why is that? Because log of a negative number is undefined. So I can only allow positive numbers. So let me plug 1 for x and 0 for y. That will give me 3, which is more than 0, which is true. What does that tell you? It means that 1, 0 is part of the domain, and 1, 0 is right here. I just placed it right there. So that's the domain. Okay, now that I got this right, let's find the gradient. In order to find the gradient, all that we are required to do is just find the partial derivatives, and we write them as a vector. Now, partial derivative of log of something, and this something is 3x plus 8y, is going to be 1 over the something multiplied by the derivative of the something with respect to x, which is just 3. Now, I can actually put 3 on the top. Again, and then over here will be the same exact thing, but 8 will be on the bottom, on the top, and 3x plus 8y will be on the bottom. Okay, so now that I found the gradient, I'm going to find the equation of the tangent plane. So how does that work? Well, first of all, you're going to need to take your point and plug it into 3 different places before you can write down the equation of the tangent plane. So your point 1/3 0 should be plugged in, number 1, into the original function. So what is f of 1/3 0? Well, this was log of 3x plus 8y. Now, this is log of 1, and everybody should know that that's 0. Now, however, if this is not 0, then you will have something else over here. So don't forget that the tangent plane starts with the value of the original function at the point. Then we add the first partial at that point, multiplied, so I'm going to still fill this out, by x minus the x coordinate of the point, plus I'm going to get the second partial at the same point, and it's going to be multiplied by y minus the y coordinate of the point. Okay, so that's my tangent plane equation, but let's see if we can plug in 1/3 first in the first partial. So this will be 3 divided by 3 times 1/3 plus 0. So I think that's 3. If you plug in the same thing in the y, you will get 8 divided by 1, which is just 8. Okay, so it looks like my equation will be 3 over here and then 8 over here. Now, it says that I'm supposed to simplify, so I probably should distribute. So this will become 3x minus 3 times 1/3, that's 1. And then plus, plus 8y. Okay, so it looks like that's my equation. So 3x plus 8y minus 1. Okay, so that's the tangent plane. So we reviewed that. Now let's talk about directional derivative. Now the good news is that we already found the gradient, but let's discuss that. So here we got the gradient of our function, and it was 3 divided by 3x plus 8y, and it was 8 divided by 3x plus 8y. So what do we need to do to find directional derivative? So first of all, we're going to plug in the point 0, 1/8 into the gradient here. So we will get 3. Now, if I plug 0 for x and 1/8 for y, this will just be 1. And then it'll be the same thing here. So I think the gradient is just equal to 3/8 at that specific point. The other thing you need to do is look at the direction, because directional derivative depends on the direction. Direction is 4/8, but you want a unit vector that has the same direction but length of 1. In order to do that, you need to find the magnitude of a, and that will be 1 over square root of 4 squared plus 8 squared. Okay, so let's see if we can compute that. That's going to be 4 squared plus 8 squared. That's 80. So that's going to be the magnitude. Okay, sorry, the magnitude is not 1 over. The magnitude is just square root of 80. You divide by the magnitude when you get the unit vector. So this will be 4 divided by square root of 80 and 8 divided by square root of 80. Okay, so that is going to be my unit vector. So let's put that in there. Okay, and then directional derivative is going to be the dot product of the gradient and this unit vector. So the dot product, remember, is just a number. So this is 3 times 4 plus 8 times 8. And then the whole thing will just be divided by square root of 80. So it looks to me like that's 64 plus 12, right? 64 plus 12 divided by square root of 80, and I think that's 76 divided by square root of 80. So that's directional derivative. Remember that this is just a number. Okay, now the last part here is to find the direction of the maximum change, and also what is that maximum change. So what we need to know for part E is that the maximum directional derivative is equal to the magnitude of the gradient at that point, not the magnitude of vector of direction A. This is nothing to do with that. Where is the gradient? Go to that. Okay, the gradient was right here, 3/8. What is the magnitude of that? So magnitude of 3/8. Again, this has nothing to do with the square root of 80 that we got in the previous case. So this will be square root of 3 squared plus 8 squared. So that's square root of 9 plus 64. I think that would be square root of 73. So that is the maximum rate of change. Now, to find the direction, the formula says that you're supposed to take the gradient and divide it by its magnitude. In other words, normalize it, okay? And that usually would be the direction of the maximum change. Okay, so this would be 3 divided by square root of 73 and 8 divided by square root of 73. That will be the direction of the maximum rate of change.